am very sorry. That somehow got cut off, so I didn't want to re-record all that, so I'll just pick it up from here. We're on part B, and I was trying to go for some new colors here. How about lime green? The software can be returned. So they said, let R represent the software can be returned. So you'd start with the R. And then you have the words if and only if. So if and only if is this double arrow down here. And then it says let B represent the statement the seal is broken. Now up here it says the seal is not broken. So there's the B for the seal is broken, but when they throw in the word not right here, you have to throw in a negation symbol right there. Okay, so that takes care of negation, conjunction, disjunction, conditional, and biconditional. Those are your 5 connectives. Now, the other thing they talk about in this section are quantifiers, and there's 2 types. There's universal and existential. Universal quantifiers are words like all, every, okay? It's like the whole, it's kind of like in the set theory when you had a universal set. These were all the numbers you had to consider for the universal set. Same concept. When you see the words all, every, it's the entire thing. When they talk about existential qualifiers, that's when you're only going to talk about some of them, or there is at least one, or there exists, which implies there might be 1 or 2 out there. That's existential. That's not when you're talking about the whole thing. You're just talking about parts of them, kind of like a subset. So they've got some examples up here of the universal ones. These are universals. All citizens over the age of 18 have the right to the vote. Every triangle has an interior angle sum of 180 degrees. Each NASCAR driver, okay? And then down at the bottom, these are sentences that use the word some and stuff like that. So down here, some drivers qualify for reduced insurance rates. There is a number whose square is 25. There exists a bird that cannot fly. Those are all existential quantifiers. Okay, whoops, I jumped ahead too far. There we go. Now, if you're asked to negate a quantifier, let's start with negating the universal quantifiers. If you want to negate an all, you're basically going to switch it from an all to a some. You would not, so when it says, suppose we want to negate the statement, all professional athletes are wealthy, you would simply change the word, let me switch, the word all, which is a universal quantifier, to the word some, which is an existential one. You would not, I'm going to highlight this in red or underline it, do not do this. All athletes are not wealthy. Because it is still, you still have an all in here. And you're still dealing with a universal. Okay? So don't put the not on the wealthy. If you want to use a not, you would have to put that not, let me go back to the green, on the all, like saying not all athletes are wealthy. So that's negating quantifiers. not negating a statement. That's my cat, sorry, if you heard that. Okay, now, if you want to negate some, which is existential, you are literally going to pull it. I guess you could go back from some to all, but most of the time it's some to none, because you're saying some students get a scholarship. By pulling these two circles totally apart, you're going from some to a none on this, which technically is universal. It's like saying it's either all or nothing on the universal. So don't try to negate the statement. When you say some students will not get a scholarship and you're putting the not on the scholarship part, you're trying to negate this statement. This part is negating the quantifier. So you want to negate the sum on this, and switching from some to none, the best way to do that. Back on that last one, when we were looking at the circles, you can see that you had a circle completely inside of another circle. And in that drawing, this represents an all. All athletes are wealthy. If you have a circle inside of a circle, you're saying that everything inside the little circle is also part of the big circle. But if you pull it away so they look like two intersecting circles, now you're saying that not all athletes are wealthy. Some of them are right here where the two circles intersect, but if you're over here where they're pointing in the light pink, that is where some athletes are not wealthy. That's the sum part. And back to this one, this is a sum because it's intersecting, and to negate it, you'd literally pull it back to out and be totally none on that. I hope that makes sense. And that is the end of the lecture part. So when I pick up my next video, we will start with some of my math lab examples.